Welcome to Teacher's Diaries. Let review online. Our subject for today is mathematics. So we have questions on calculating probabilities. So let's start with number 1. So this is the first problem. You have a bag of red, white, and blue marbles. You know there are 11 red marbles, 8 blue marbles, and 3 white marbles in the bag. What's the probability of randomly selecting a blue marble from the bag? A. 0.275, B. 0.364, C. 0.375, and D. 0.500. Okay, let's proceed to number 2. The probability that a white adult man with a high white blood cell count contracts leukemia is 0.35. A proper interpretation of this probability is: A. There's a 35% chance that a randomly selected white adult man will contract leukemia. B. 3 out of every 5 white adult men with a high white blood cell count will contract leukemia. C. There's a 65% chance that a randomly selected white adult man with a high white blood cell count will contract leukemia. And D. We'd expect that in a sample of 100 white adult men with white blood cell counts 35% will contract leukemia. Okay, let's proceed to number 3. A doctor conducts blood tests on a random sample of 800 white adult men. He finds that 275 have high white blood cell counts. Using the probability that a white adult man with a high white blood cell count contracts leukemia is 0.35, compute the expected number of men in a sample who will contract leukemia. A. 280, B. 275, C. 179, and D. 96. Number 4. The set of all possible outcomes of a probability experiment is called what? A. Experiment, B. Complement, C. Venn diagram, D. Sample space. Next. Number 5. Which of the following are true? First statement: two events are mutually exclusive if they can't both occur at the same time. Second statement: two events are independent if they have the same probability. Third statement: an event and its complement have probabilities that always add to 1. These are the choices: A. First statement only, B. The second statement only, C. Third statement only, D. First and the third statements only. Let's proceed to number 6. A jar contains 5 coins, 2 pennies, 1 nickel, and 2 dimes. You draw 1 coin at random. What is the probability of selecting the nickel? What's the probability of selecting a dime? A. 1 over 5 and 2 over 5. B. 1/3 and 1/3. C. 2 over 5 and 1 over 5. D. 1 over 5 and 2 over 4. Next. Number 7. You flip 4 coins. What's the probability of getting exactly 4 heads? A. 1 over 16. B. 4 over 16. C. 6 over 16. And D. 2 over 16. Let's proceed to number 8. You flip 4 coins. What is the probability of getting exactly 2 heads? A. 1 over 8. B. 5 over 8. C. 3 over 8. And D. 1 over 4. Number 9. You flip 4 coins. What is the probability of getting at least 2 heads? A. 1 over 8. B. 5 over 8. C. 3 over 8. And D. 11 over 16. Number 10. For question number 10 to 12, refer the following information. You have 2 special created dice. Each die has 6 sides. The first die has the numbers 1, 3, 5, 7, 9, and 11 on the sides. And the second die has the numbers 2, 4, 8, 10, 11, 15 on the sides. Here is the question. If you roll the 2 dice, how many possible outcomes are there? A. 6. B. 12. C. 24. D. 36. Let's proceed to number 11. Question 10 to 12. Refer the following information. You have 2 specially created dice. Each die has 6 sides. The first die has the numbers 1, 3, 5, 7, 9, and 11 on the sides. The second die has the numbers 2, 4, 8, 10, 11, 15 on the sides. And here is the question. You are about to roll only the second die with the numbers 2, 4, 8, 10, 11, and 15 on its sides. Estimate the probability of getting an odd number on a single roll of this die. A. 0.167. B. 0.333. C. 0.056. And letter D. 0.500. Next. For question 10 to 12, refer the following information. You have 2 specially created dice. Each die has 6 sides. The first die has the numbers 1, 3, 5, 7, 9, 11 on the sides. The second die has the numbers 2, 4, 8, 10, 11, 15 on the sides. Here is the question. Which of the following would not represent an instance of independent events when using the 2 specially created dice? A. Getting an odd number on the first die and getting an odd number on the second die. B. Getting a 9 on the first die and getting a sum of 19 on the 2 die combined. Letter C. Getting a 2 on the first die and getting a value greater than 10 on the second die. Letter D. Getting an even number on the first die and getting a 15 on the second die. Number 13. Excuse me. You have 6 different cards with colors on both sides of the card. The first card is green and green. The second card is green and blue. The third card is green and red. Fourth card, red and red. Fifth card, green and green. Sixth card, green and blue. You're shown a card with a green face showing. What is the probability that the other side on the card is not green? A. 20%, B. 50%, C. 60%, D. 66.7%. Next, one card, number 14, one card is randomly selected from a standard 52 card deck. Find the probability that the card is an ace or a black card. A. 1 over 26, B. 1 over 13, C. 7 over 13, D. 15 over 26. Next, number 15. One card is randomly selected from a standard 52 card deck. Which of the following gives the probability that the card is a black ace? A. 1 half plus 1/3 minus 2 over 52. B. 1 half times 1 over 13. C. 1 over 52. D. 1 half plus 1 over 13. Next, number 16. Which of the following are true? Statement 1. If events A and B are independent, P of A or B is equal to P of A multiplied to P of B. Event 2. If events A and B are independent, P of A is equal to P of A independent of B. Statement 3. If events A and B are disjoint, P therefore P of A or B is equal to P of A plus P of B minus P of A and B. And these are the choices. Letter A, the first statement only. Letter B, second statement only. Letter C, third statement only. And letter D, second and third statement only. Let's proceed to number 17. Which of the following statement is correct? A. The probability of any given outcome for a discrete random variable is 0. Letter B. The area between any two x values under a density curve is 1. Letter C. A random variable can have either numbers or categories for its values. Letter D. A random variable must have a number as its value. Next, number 18. The following table is for a discrete probability distribution. For x in the first row, he got 7, 3, 9, 11, and 15. And for the p in the second row, 0 0.05, 0 0.10, 0 0.15, blank, 0 0.25. Question: what number is missing? A. 0 0.45, B. 1, C. 0 0.6, and D. 20. Next, number 19. Which of the following are discrete random variables? First statement, the enrollment at state universities. Second statement, the outcomes of a loaded die. Third statement, the set of all random numbers between 1 and 10. Choices. Letter A, 1 only. Letter B, second statement only. Letter C, third statement only. Letter D, the first and the second statement only. Okay, last number before we start giving the answer and the explanation. Number 20, the random variable, which is x, has a normal distribution with mean 25 and standard deviation 4. Which of the following is closest to p of 20, p of x, in which x is greater than 20 and x is lesser than 26? So for this question, you can use a standard normal distribution table or you may use your calculator. Okay, so letter A, these are the choices. A is 0.493, letter B 0.680, letter C 0.348, and letter D is 0.482. Alright, so that would be all for our questions. And right now, let's proceed to rationalization or the answer key and explanation on a certain problem. So let's start with number 1. So you have a bag of red, white, and blue marbles. You know there are 11 red marbles, 8 blue marbles, and 3 white marbles in the bag. What's the probability of randomly selecting a blue marble from the bag? Now we got these choices. The correct answer is letter B. It's 0.364 because in total there are 22 marbles in the bag. Since 8 marbles are blue, the probability of selecting a blue marble from the bag is 8 over 22 or 0.364 if we try to make it into decimal form. So this means there is a 36.4% chance of selecting a blue marble. Okay, so that would be the explanation why the answer is letter B. Now let's proceed to the second item. Okay, so the probability that a white adult man with a high white blood cell count contracts leukemia is 0.35. A proper interpretation of this probability is A. We've done reading all of this, so let's proceed to the correct answer. The correct answer is letter D. So we had expect that in a sample of 100 white adult men with high white blood cell counts, 35% will contract leukemia, and this is the explanation. So we'd expect that in a sample of 100 white adult men with a high white blood cell counts, 35 will contract leukemia. This probability indicates that there are 35% chance that a white adult man with high white cell counts will contract leukemia. So that probably the answer on question number 2. Okay, and let's proceed to number 3. So for number 3, a doctor's blood test on a random sample of 800 white adult men, he finds that 275 have high white blood cell counts. using the probability that a white adult man with a high white blood cell count contracts leukemia is 0.35. Compute the expected numbers of men in a sample who will contract leukemia. So our answer is 96, and this is the explanation. The probability refers to the likelihood that an individual with high white blood cell counts will contract leukemia. In our sample, we know that 275 out of 800 have high white blood cell counts. The 275 white men are the population at risk. At this point, we multiply the population at risk by the likelihood of contracting leukemia and making it 275 times 0.35. So this will equal roughly 96 individuals. So this approximately 96. So we're going to choose the you know um, the roughly, since the answer is roughly 96, then we choose 96. Okay. Now let's proceed to number 4. The set of all possible outcomes of the probability experiment is called the blank. The answer is sample space, because the sample space shows all the possible outcomes of a probability experiment. Let's proceed to number 5. Which of the following are true? On these three statements here. So the correct answer is letter D. 1 and 3 statement, 1 and the first and the third statement only. So mutually exclusive events are also called disjoint events, and can't occur simultaneously. So since the complement of an event is the instance where an event does not occur, it makes sense that the probability of the event and its complement sum to 1. So the final answer is the first statement only, and the first and the third statement only. Okay. Next, number 6. The correct answer is letter A, because since there are 5 coins and only one is nickel, then the probability of selecting that nickel is 1 over 5. And 2 of the 5 possible outcomes are dimes, giving a probability of 2 over 5. So the answer is letter A. Now let's proceed to number 7. So here we try to get exactly 4 heads in flipping 4 coins. Now the final answer, or the correct answer, is 1 over 16, because each coin has 2 possible outcomes. It could be heads or it could be tails. If you flip 4 coins, you have a total of 16 possible outcomes. Just simply 2 times 2 times 2 here, that would equal to 16. This would be the first toss, the second toss, third, and the fourth. And that would include that there are 16 possible outcomes. Now the event HHH occurs only once out of 16 times. Thus, the probability is 1 over 16. So the answer is letter A. Now let's proceed to number 8. Here we try to get exactly 2 heads. Okay? Exactly 2 heads only. Alright? Now, the answer for this problem is 3 over 8, because if we try to flip 4 coins, the sample space consists of 16 possible outcomes. That would be these outcomes here, okay, or sample space. Now we can see that you would get exactly 2 heads in 6 different outcomes. It could be HHTT, HTTH, HHT, I mean HTHT, TTHH, THTH, and THHT. So if, as you can see, in every outcome, there is only exactly two heads on a certain outcome. And these are 6 outcomes here. So therefore, the probability is 6 over 16 or 3 over 8. Reduce it into 3 over 8. Okay. Now let's proceed to number 9. Same, flipping 4 coins, but here it's not exactly 2, but at least getting at least 2 heads. Okay. So if the answer here is letter D, because same earlier we have 16 possible outcomes, but what we try to look for now is the least, at least 2 heads. Now these are the events, I mean the events at least 2 heads, because we can see that you would get at least 2 heads. It means 2 or more. Okay, if we say at least 2 heads, it means 2 or more, because the 2 is the least. Okay, it could be 3, it could be 4 if possible, right? Since we only flip 4 coins, so the largest number of heads is only 4. Okay, so at least 2 head means 2 or more. So we can have HHH, HHHT until to THHT. So if we try to count all of these outcomes here, then we can get 11 out of 16. Therefore, the probability is 11 out of 16. Now let's proceed to number 10. So this number 10 is a series problem. So we have question 10 and 12 here, refers the following information. So we have 2 specially created dice here. Each die has 6 sides. The first die has the numbers 1, 3, 5, 7, 9, 11 on the sides. The second die has the number 2, 4, 8, 10, 11, 15 on the sides. So this is the question in number 10. On number 10, if you roll the 2 dice, how many possible outcomes are there? So the answer is letter D, 36, because if we try to create a sample space on the possible outcomes, you will find that there is a 6 by 6 matrix of outcomes, or 36 possible outcomes. This is the same number of outcomes as if you used a normal set of dice. Okay, let's proceed to number 11. Same information. Okay, so we have this information, and let's proceed to the problem. So you are about to roll only the second die. Okay, only the second die, this second die, with the numbers 2, 4, 8, 11, 15 on its sides. Estimate the probability of getting an odd number on a single roll of this die. A 0.167, B 0.333, C 0.056, and D 0.500. The answer here is letter B, because there are 6 possible outcomes for the roll to the of the die 2, 4, 8, 10, 11, and 15. And you know that 2 of them are successful outcomes, odd numbers, because our event here is odd numbers. Thus, the probability of rolling an odd numbers is 2 over 6, or 1/3, or 0.3333. So the answer is letter B. Now let's proceed to the next problem. Same information. Number 12. Here is the question. Which of the following would not represent an instance of independent events? Okay, again, which of the following would not represent an instance, of independent events when using the 2 specially created dice? A, getting an odd number, on the first die and getting an odd number on the second die. The correct answer here on this problem is letter B, because getting a 9 on the first die and getting a sum of 19 on the two dice combined, when events are not independent, the probability of one event is affected by the probability of the second event. In this case, the probability of getting a sum of 19 across the two dice is clearly affected by the probability of getting a 9 on the first die. For example, this probability of a sum of 19 is far more likely if you get a 9 on the first die than if you get a 10 on the get a 1 on the first die. Okay? So basically, this is not, the answer here is letter B, because um, this is not independent events. Now let's proceed to number 13. You have 6 different cards with colors on both sides of the cards. These are the cards. So the answer here is letter C, 60%, because there are 5 possible cards with a green face. You know that of these 5, 3 have a different color on the other side. Therefore, the probability of not finding green on the other side is 3 over 5, or 60%. So the answer is letter C. Next, number 14. One card is randomly selected from a standard deck of cards. Find the probability that the card is an ace or a black card. The answer is 7 over 13. And here is the explanation. If we apply the general rule, P of ace or black card is equal to P of ace plus P of black card minus the P of ace and a black card. That "and" signifies the intersection or intersect on both ace and black. So we can find that P of ace is 4 over 52. It would be equal to 1 over 13 if we try to reduce. And the P of black card is 1/2 because it's 26 over 52. Okay? And the P of ace and a black card, or the intersection between the ace and the black card, is 2 out of 52. So which accounts for the 2 black cards, aces in the deck. So therefore, P of ace or black card is equal to 1 over 13 plus 1/2 minus 2 over 52, and that would include or conclude 7 over 13. Now let's proceed to the next item, number 15. So one card is randomly selected from standard deck of cards. Which of the following gives the probability that the card is a black ace? A, 1/2 plus 1 over 13 minus 2 over 52. So let's make it short. The answer is letter B. Since the events are independent, take note, it is independent. The P of ace and black, it will equal to P of ace times P of black, or 113 times 1/2. Okay? It could be interchanged, 1/2 or 113, because it is multiplication. Now let's proceed to number 16. So which of the following are true? So we have 3 statements here, and the correct answer is the letter D. The second and the third statement, or statements only. Statement second or 2 tells you that when the events are independent, the probability probability of a single event is equivalent to the probability of that event given a second event. So this makes sense, because if B has no influence on A, then P of A independent to B should be the same as P of A. In statement 3, you see the general rule for the union of events, and this rule applicable whether or not the events are disjoint. Now let's proceed to number 17. So which of the following statement is correct? a probability of any given outcome for a discrete random variable is 0. That would be the choice of letter A, but let's make it short. The answer is letter D. A random variable must have a number as its value because, this is the explanation, a random variable must have a number as its value. Random variables must always have a numeric value. They can't be nominal or categorical variables. Okay, so the answer will, will be letter D. Number 18. Now, the following table for a discrete probability distribution, as you can see here, and the problem is what number is missing. So this is the problem. One. So the correct answer is letter A, 0.45, because if you add up all the known probabilities in the probability distribution, this one, if you try to add up here, the remaining probability must be the difference between these and 1, since the total probability distribution has the sum of 1. So therefore, that would include, or that would conclude, that the answer is letter A, 0.45, because this is 0.25 plus 0.15 is 0.40, this is 0.50, and this is 0.55. So 1 minus 0.55 is 0.45. So the answer is letter A. Now let's proceed to number 19. So which of the following are discrete random variables? We have three statements here. The correct answer is letter D. The first statement and the second statement only, because enrollment may be a large number, but it's still be discrete because it's a count of people enrolled. The outcomes of loaded die are discrete, though the outcome aren't equally likely. However, the set of all random numbers between 1 and 10 is infinite. Therefore, it's a continuous random variable. Again, the set of all numbers, the set of all numbers between 1 and 10 is infinite. Therefore, it's continuous random variable. Okay? In what case or scenario? Like let's just say 1.01. Okay? The next is 1.01, next 1.001, again 1.0001, and that is would include an infinite numbers here because that is from 1 until 10. So therefore, it is continuous. Okay? So correct answer is letter D. Next is number 20. The random variable x has a normal distribution with mean 25 and standard deviation of 4. Which of the following is closest to the probability of x, or p of x in which x is greater than 20 and x is lesser than 26? So for this question, you can use your calculator or a standard normal distribution table. Now, if you are in the let, so you may use your calculator on this one. So the correct answer is 0.493. So the area or probability in question is below the normal curve between z is equal to negative 1.25 and z is equal to 0.25. You can also answer this question using your TI-83 or any calculator that has this program using normal CDF 20, 26, 25, and 4. So this 20 here is this one, the list of this this problem here. The p of x is greater than 20, then the p of x is lesser than 26. So the lower limit here is 20. So this is the lower, and the upper is 26, and the 25 is the mean or the normal distribution mean here, and the 4 is the standard deviation. So note that the TI-83 is a model of a calculator from the Texas Instruments Company. So we can use either any calculator as long as there is a normal CDF like this one, or it is um, what do you call this one, if they are ready or programmed by this problem. Okay, alright, so that would be all for this, and please don't forget to subscribe for more videos like this, and good luck and God bless, teachers. So from the Facebook page, you may click the link below here, this one. We will also put it in below or in the description page. Alright.